Hello friends, welcome to Learn Positive with Pradeep Kumar. If you're watching my channel, like, share, comment, subscribe, click the bell icon. So today's subject is manufacturing process. Unit 1, Foundry Technology, part 15. If you want to see my previous parts in this subject, click the I button on the top of the video. You will see the subject playlist. And if you want to see more subjects, visit my channel and see all the playlist. And don't forget to subscribe. So today's topic is continuation of the previous video. It was iron carbon equilibrium diagram. I will explain it once again. So what is iron carbon equilibrium diagram? It is a graphical representation of two phases, that is percentage of carbon and also the temperature of the steel. So due to the temperature variation, the microstructure of the steel may vary. So we are going to calculate the temperature in y-axis and also the percentage of carbon present in the steel iron is calculated in the x-axis. So we are going to plot the variation of temperature and variation of the carbon percentage in the graphical structure, and we can study the exact process happen while the heat treatment is started and ended. So we are going to record the diagram, equilibrium diagram of iron carbon equilibrium diagram. So it is calculated for the steel itself. Now we are going to see the diagram of iron carbon equilibrium diagram. This is the graphical structure. Here in x-axis we are going to see percentage of carbon, and in y-axis it was the temperature, varying of temperature from 0 to 1800 degrees Celsius. So above the temperature we are going to see it was a in a high critical temperature it was going to be a form of delta region. So it reached the delta region. It is said to be the delta ion, so near to the molten stage, and the lower part of the ion is alpha region. So alpha region is nearby 723 degrees Celsius. So it is said to be the lowest region of the heated steel. And also due to the carbon variation, the steel is converted into cast iron. So below the 2% of steel we are going to set below the 2% of carbon we are going to set the metal as the steel, and increasing the percentage of carbon above 2% it becomes cast iron. So in between that 0 to 0.8% is the hypoerectoid steel, and it is said to be from 0.8 to 2%, it is the hypererectoid steel. So steel is divided into two conversions. One is hypoerectoid and another one is hypererectoid. Now we are going to see part by part what are the variations happen in the steel during temperature and carbon variation. The first one is description of the video. Let us consider the portion of the diagram in the upper left hand corner near point A. It is said to be the delta region. So delta region has the solidification of carbon up to 0.05%, and the delta region is no important to industrial application because it is the region no heat treatment process is carried out, because the metal is at the melting stage. So in the molten stage we cannot use the metal for industrial application, so it is used for only the casting applications. Then when the metal is going to be cooled rapidly by starting solidification, it is said to be the line called Liquidus line. It is shown as blue line in the below diagram. So it has the carbon content of 4.3%, starts solidification into gamma ion from the delta ion. So we are going to create the gamma ion. We are going to decrease the temperature up to 1130 degrees Celsius at the point C. And now the solidification is complete along the line AGC. So it is called the Solidus line. So the AGC given in this diagram. So A, G and C, it was shown as the green line. So it is the Solidus line. So the Solidus line cools the metal from the delta ion to sorry from the delta ion to gamma ion. So the gamma ion has the astenate structure. The astenate structure is most important structure in the steel. So the ion contains 2% of carbons. To solidify the complete gamma ion along with the line Ag shown in the diagram, first diagram, as in the green line. And then in the region AGKI, you can see it in the second diagram, A to G and G to K and I. So it was shown in the brown line. It is said to be the critical temperature line. So it creates the alpha ion into the beta gamma ion into the beta ion by using the astenate structure, changes of astenate structure. That point of Solidus line got 2 to 4.3% of solidification below the line GC. So below the line GC, we are going to reduce the temperature to, so it will create the astenate structure with cementite structure. And now the point K, the metal contains 0.8% carbon. The gamma ion with austenite structure is fully converted into pearlite structure upon the cooling of 723 degrees Celsius. So in the point K, that the metal was cooled up to 723 degrees Celsius from the temperature of 1130 degrees Celsius. So it is called as the point K. It is called as eclectoid point. So the eclectoid point have two types of steels. One is hypo and one other is hyper. So hypoeclectoid and hypereclectoid. Hypoeclectoid contains less than 0.8% of carbon, starts from austenite to ion to ferrite ion. It is the beta ion. So gamma ion to the beta ion. And then in the region IKL, so IKL, the melt exists in austenite and ferrite structure. So alpha plus gamma ion, it is said to be the alpha plus gamma ion. In this structure, when the cooling is further taken, so it is formed to the pearlite plus ferrite structure. After we getting the ferrite structure, we are going to take hyper eclectoid steel. So it is the solidification carbon of 0.8% to 2% of carbon, has the austenite plus cementite structure above the eclectoid temperature line LKM. It was shown in the green line. When it is cooled, the structure of the metal is transferred into ferrite plus cementite. So when we are going to mix the ferrite and the cementite structure, the line was formed. And the liquidized line, in the liquidized line shown in the diagram as the green line, A, B, C and D, the molten metal is going to be cooled from 1530 degrees Celsius to 1130 degrees Celsius. So when we are bring it to decrease, by decreasing the temperature of it, we are going to get the point of pure solidification. At the point C, the temperature was decreased, and the carbon percentage was increased above the 2%. So it is said to be the ion is said to be the cast ion. The point C represents the solidification temperature of ion 1130 degrees Celsius with the carbon percentage of 4.3% of carbon. So when we are increasing up to above the 2% of carbon, so it is said to be the cast ion. So it is used for the casting purposes. And the line CD shown in the solidification temperature in the green line, from the C to the D, the temperature was increasing when the carbon is increasing above 4.3 degrees Celsius. So when it is above the 4.3 degrees Celsius, the cementite is mixed with the liquidus line. So it has the carbon up to 4.3%. And the Solidus line, is below the liquidus line. So it is the A, G and CH. So the line AgCH is shown in the Solidus line. The ion exists in solid state of temperature below this line. As the line goes gradually down from A to G by reducing the temperature and increasing the carbon percentage to solidify the ion. And the point G represents the solidification temperature of ion up to 1130 degrees Celsius with the carbon percentage of 4.3% of carbon. The diagram is divided into two parts based on the carbon content. The part at up to 2% of carbon is said to be the steel range, and the part with more than 2% is said to be the cast iron range. The steel contains less than 0.8 degrees Celsius is said to be the hypoelectroid steel, and exactly 0.8% said to be the electroid steel, and more than 0.8% up to 2% it is said to be hyperelectroid stage. In these three stages we have three types of metals. So the first one is less than 0.2 percentage we have, it is the hypoelectroid steel. It is the steel is said to be the low carbon steel, and the steel from 0.2 percentage to 0.8 percentage, it was the steel called hypoelectroid and also electroid. So these two steels have the type of mild carbon steel, and also the next one is the steel have the percentage of 0.8 to 2 percentage. So it was the maximum percentage of carbon present in the steel. So it is said to be the high carbon steel. So when the maximum carbon percentage is increased, so the steel is otherwise called as hyperelectroid steel. In the type of hyperelectroid steel we have high carbon steel. And now we are going to see the critical temperature. In critical temperature we have to see two of the critical temperatures. The one is upper critical temperature and another one is lower critical temperature, that is said to be the UCT and also LCT. The upper critical temperature, the molten up to the molten metal is solidified and cooled down from the 1130 degrees Celsius to 723 degrees Celsius. So it was shown in the green structure. Now the iron goes to heated and changes temperature from 723 degrees Celsius to 1130 degrees Celsius. It is said to be the upper critical temperature. So UCT, the temperature at which the microstructure is completely changed by reducing the temperature, it is solidified, and the point is said to be the lower critical temperature. So it is 723 degrees Celsius, LCT, lower critical temperature. It was shown in the diagram in blue color. The line LKM is a constant temperature. So the constant temperature line that is 723 degrees Celsius, the line is called electroid temperature line. It is low critical temperature line also. It was shown in the figure in the green line. So the line never changes. So if friends, if you like this video, give a thumbs up, share with your friends, don't forget to subscribe. Thank you.